Hi, everyone. Today I want to talk about uploading really large files to AWS. Now, this is a complex issue. It can be done in a few different ways, but there's definitely a proper way to do it. Now, I had to accomplish this fairly recently on a large project and learned a lot by doing it, and also learned there wasn't the greatest documentation for it. It was kind of hard to piece together. There's a lot of little nuances that would come up in configuring everything, and I figured, this is a great topic that I think could come in handy. So I want to start by kind of setting the stage and just explaining, a few different ways you could upload files to an S3. So first of all, simple uploading. This is like the basic way that you've probably done before if you've, built any kind of uploading that relies on a server. So basic upload. Browser would be like, hey, I want to upload this file. They send the file to the server. The server essentially receives it, but we can also think of them downloading it because every time an upload's happening, a download is happening as well. Now, in an ideal world, the server also can kind of determine the URL of what the final upload will be at this point and actually send it directly back to the browser to be like, hey, here's the URL. It might not be ready yet, but here's the URL. Store this, do what you want with it. Cool, cool. And that allows it to then asynchronously then actually upload the file to Amazon, you're not actually like holding up. Now that's not always the case. Sometimes this determining URL step is completely missed too, and the browser is actually waiting for this whole proxy to happen, right? Going from the browser to the server to AWS, and then AWS saying, yeah, it's ready, and the server kind of saying, okay, here's your URL. So that's like the basic way. It has a lot of downsides. One of them is you're essentially wasting, resources of your server, bandwidth costs. There's a lot of potential for timeouts here, and many modern web applications, especially if you're following like the 12-factor app, or for especially if you're using something like Heroku, you kind of have this like 30-second timeout there that if any HTTP process takes that long before a response happens, it's just killed. So the browser doesn't know, what happened. So we can, get around this in a slightly better way, and I'll show you the pre-signed URL option. And this is a pretty common way of doing things. And if you watch some of my videos recently, ServerPod actually does it this way, which is handy. They kind of do it all under the hood. You don't really think about it, but essentially the way it kind of works is browser tells the server, hey, I want to upload a file. Here's some metadata about it, usually like the name and the content type. The server goes and it talks to essentially Amazon, and Amazon sends back this sort of like pre-signed URL that's like a temporary URL that has like a token in it and all this kind of stuff, but it's only going to work for, maybe the next few minutes. So it's not something that, if someone gets that URL, they can just send it to all their friends and be like, hey, a free place to upload things. It's just meant for that thing. So the server then sends that URL back to the browser, and now the browser actually goes and uploads it directly to S3, which now the server is not being used as a proxy. There's no longer this timeout issue that you might have, and you're not really wasting like resources on bandwidth and even just like server processing, because it's really just doing this quick communication with some metadata, and then the browser is talking directly to S3. And this is a great way of doing it. However, there are some issues with it. One being that, at least on Amazon S3, you only have a 5 gigabyte limit here. Now that sounds like a big, a lot of data. And for most use cases, you're going to be totally fine doing it this way. If 5 gigabytes is a lot, but the application I was working on needed to support, much more larger file sizes in some edge cases, and this would just break. Amazon would say no, it would essentially like cancel the request as soon as it hit that 5 gigabyte size. So the third way of doing things is a multi-part upload, which I will walk through in a minute, but I want to talk about some advantages of this, seeing that it's complex. First of all, instead of 5 gigabytes, it's 5 terabyte maximum. That's almost 5 terabytes more than 5 gigabytes. Speed-wise, this is also has some advantages because you're sort of uploading things in parts. The entire file doesn't have to like be read into memory first and then go up and kind of be sent up in chunks. And you can even, in theory, do this in parallel too, where you're using multiple, you're sending it in multiple chunks kind of simultaneously if your browser supports that. It's also a more reliable way of doing things. If a network issue happens partway through, it'll just be that chunk that needs to kind of restart and do instead of the whole thing from scratch. This also supports the ability to have like a pause and resume uploading feature in your front end, where you can essentially be like, hey, this is taking a long time. Give your user an option. Hey, pause this for whatever reason. Come back later and resume it, because it doesn't actually have to restart the whole thing. It just have to restart a chunk, and the chunk can be pretty small. And another advantage is, you could, in theory, build a way based on the end user's bandwidth to actually change the chunk size dynamically. Someone on 3G or something, maybe it's like really tiny chunks and there's many of them, versus someone who's connected to a really good internet connection. You could optimize it a bit differently. So, how does this work? So it starts off kind of similarly to pre-signed. So the browser's like, I want to upload this big file, right? Now, they're not just going to send that metadata of content type and name, but they're also going to send the file size. Then the server's like, cool, okay, I'm going to talk to S3 and kind of forward that info. And now S3 and Amazon in general is going to send back a whole list of URLs. So instead of just one pre-signed URL, it's actually a whole bunch of them with some additional metadata on it. The server then passes that back to the browser, and the browser now can basically chunk up that file and send them to each of the predefined URLs, again, potentially in parallel. Once that's done, so every time that chunk is uploaded, in the header, the browser's getting an e tag back, which is kind of like just a something that's saying, hey, this is the version of this file. It's like a string of characters. You'll see it in a little bit. And what the browser is going to do is collect those as it's going. And when it's done all the chunks, it's then going to hit the server again to send up all those final e tags. And the server is going to send those e tags essentially to a completion function of the S3 library, and which finalizes the file, essentially stitches it all back together, and then everything's good. So it's definitely complex. Like, there's a lot of stuff going back and forth here, but we have some huge advantages. We're not actually ever uploading a large file to our server. We have things in chunks. We can do things in parallel. It's very, in my experience, it's very reliable. Uploading large things. Like, imagine being able to upload 5 terabytes just from your browser, without actually a server in the middle, other than it kind of managing and orchestrating, the stuff on your behalf. And in general, something I didn't touch on in either of these, really all of these, is, of course, you could, just upload directly to S3 from your browser without a server, right? However, doing that would mean you have to expose to your client, to the client-side code, your S3 or your Amazon credentials, your key and your secret key. That needs to be stored on the server. You can't do that. The second you do that, if someone finds it, now they're just going to do who knows what, whatever you've allowed that key to do. And at the very minimum, they could just start uploading stuff. Having the server in the middle kind of hides your keys, but it also allows you to, potentially do things authentication-wise on the user. Is this user even allowed to upload files based on their account type, or are they already at a max? You can also assign these files that are uploaded to a specific user, saying they're the owner of it. Now, who knows what you want to do with that, but the idea is that you can do all this stuff and connect it to your database. So we need that server in the middle for, obviously, security wise, as well as just any kind of management of that data itself in the database. So that's that's kind of my overview, setting the stage. The tools that we're going to use in this tutorial. So we're going to be using, on the back end, on the server side, we're going to be using Python with a fast API. Now, 95% of this code is just Python. It's kind of framework agnostic. So if you want to use Flask, if you want to use Django, if you want to do it in something I don't even know about, you could totally follow along with this and just have to make the slight changes based on the framework you're using. In theory, too, you could learn this, and maybe you don't use Python, but you could definitely apply this to Node. You could apply this to PHP. Heck, you could, make your own programming language and then just use the AWS API to do all the, the complex stuff that I'll be showing you. It's really, although I'm using Python, it can be done really in anything, because this is more a, a methodology and a pattern that I'm trying to teach here than actually the implementation, although we will have a full working implementation in Python. On the front end, because we obviously have a browser here, I'm going to be using Vanilla.js because I figure this is actually the easiest way to show it and be adapted to any JavaScript framework that you're familiar with. So it's just vanilla JavaScript, and all JS developers are familiar with vanilla JavaScript and very competent in it, right? right? Like, I'm pretty sure. Okay, so yeah, I'm going to get this booted up and we will get started on the back end. All right, here we are in just a completely empty folder open in VS Code. Now, the first thing we're going to want to do, of course, it's Python. We need a virtual environment. So I'm going to do Python 3-m venv venv. And that will create a virtual environment in a folder called venv. There we go. Now we'll want to activate that. So we can just go source venv bin activate. All right. So now we're activated and we can start installing things. We're just going to start by installing Fast API. Like I said previously, if you want to use Flask, if you're more familiar with that, even if you want to use Django, you could definitely follow along with this, assuming you understand those frameworks on how to sort of make the adjustments for the actual API routes. Okay, so we have that. Let's make a main.py. And one other thing we need to install is, in order to actually run our server, is we need to install uvicorn. So it's like unicorn, but with a V. So we'll just do pip install uvicorn. And I'm just going to do a pip freeze to check what we actually have here. It's going to have quite a few things because installing Fast API and uvicorn came with some other things, some other dependencies. What I'm going to do is the ones that I've manually installed, I'm going to make a new file called requirements.txt and just put the ones that I actually manually installed rather than all of them, because we just want to keep the ones that we've installed here. Now, this means if we ever need to completely reset our virtual environment, we can actually just we can go pip install -r and pass in requirements.txt, and it will actually just install these as well as its dependencies. So just keeps things nice and good and a normal thing in a Python project. Okay, so now that we have Fast API, let's import Fast API, and let's actually create an app. We'll call it we'll call it app, and we'll just instantiate Fast API. Now we're going to set a couple routes here, and we'll just start by, just to kind of get an idea of it, let's just make something called hello world, and here we'll just do async def, and we'll give this a name like hello world. It can be called anything you want. And in this, let's just actually try returning something like hello world. So this is our basic, hello world to make sure stuff is working. Now, in order to actually run this, we just need to use uvicorn. So I can just go uvicorn. Oops, I put an N there. uvicorn. And then main, because that's the name of the file, and then app, because that's the app that we want to run. And we'll actually do reload, just so that it actually has a hot reload when we are making changes. Okay, so now if I actually open this up right here and go to /hello world, we should see hello world. Let me just zoom that. Look at that. It's working. Everything's great. Now what's cool about Fast API is we automatically get docs. So we can actually go /docs and we actually get a Swagger implementation, and we can actually try it out right in the browser instead of having to go to those URLs, and we can see we got it back. So we're going to be using Swagger for some of this because what we're building in the API, aside from when we actually host the front end, is going to be basically a headless service, an API that we're building. So we're not going to have a nice UI to work with until later in this when we actually implement the front end. Okay, so that's all good. Now, something we are going to want to serve, speaking of the front end, is I'm just going to copy this, and we will just call this, we'll just do this right at the root, and we'll just call this index. And here, what I actually want to return, if someone comes to the root of our project, we actually want to just return we're actually not going to serve an API here. We're going to serve an HTML file. So here I want to return a file response, and we'll just pass in index.html. Now we need to import file response, and we can get that by going from starlet import file response, and it's actually, starlet.response. Import file response. Now in our root, we will also make an index.html, and let's just go and, just for now, just make an h1 that says hello. I just want to make sure, we can serve also, although Fast API is not really meant for serving HTML for the purposes of this. Instead of us spinning up a whole other process, we're going to do it this way. So now if I actually go to the root, we'll get out of the docs here. We'll actually see hello here. So we're actually getting HTML back, which is going to be helpful when we do our front-end implementation. Okay, cool. So that's, we have a bit of a setup happening, which is great. Next, because we're going to be dealing with uploads, I want to make a new file for this. We're going to make something called upload_client.py. And in here, we're going to do a few cool things. So we're going to make a class just called upload_client, and we're going to have essentially something called S3, which we're going to set to none. And in our initialization of this, we're going to actually init that. So we'll just do def init self. And we're going to self.s3 is going to be equal to something. Now for this, we're actually going to be using a Python library called Boto3 so that we're not actually writing all the AWS API stuff on our own. Boto3 is awesome. And let's just get that installed. So we'll do pip install Boto3. And everything's good. And let's make sure we remember in our requirements that we have Boto3. So I'm just going to grab this here, the version that got installed, and just make sure you change that dash to an equals so that we have the right version there. So now we can actually install Boto3, and we'll just import it as Boto3. There we go. So with our Boto3, now we can actually go boto3.client, and now we can actually initialize the client. We specifically want to be working with the S3 client, and we're going to want to be putting some keys in here, essentially our AWS access key, our secret key, and what region we're going to be using for our bucket. So we'll get to that in a minute. Now I want to do this in a safe way and also a more maintainable way. In the theory, you know, I'm working on this locally on my machine. I might be using like a test S3 account or test Amazon account, whereas in production I might want to use something else. So we're actually going to create a .env file right in our root directory, and in here we are going to put a few things. So I'm going to first of all put these guys in. So AWS storage bucket name right here, AWS default region, and then we're also going to be putting in our access ID, which is kind of like the public key. So I could safely actually put that in if I wanted and show you, and it wouldn't be a problem. But obviously the secret key, you know, I don't want to do. So this is something you'll have to get from your Amazon account through your credentials manager. I'm not going to show exactly how to do that. There's a million, you know, tutorials I'm sure on that. I'm sure you've already done it if you've ever uploaded something to S3. But you're going to want to put these in here and keep them safe. And this is a file obviously you wouldn't want to version control. So let's actually just make a git ignore file before we forget, and let's just put .env in there. While we're at it, let's also go to I like this site, gitignore.io. And we can actually type in things like Python. I'm going to type in Mac OS because I'm using that. And we can actually get sort of an example thing here. And I'm just going to replace it all because I happen to know that .env will already be part of this. There we go. Also, our venv shouldn't be version controlled, all that kind of stuff. So now when we do actually initialize as a Git repo, which I'll do right now, git init, things like our env, and our venv will be ignored, which is, you know, what we want. We don't want those to actually be committed. Okay, now how do we actually access those? So for that, we're going to install something called python.env. So we'll do pip install python-.env. Okay, so we have that installed, and similarly, let's make sure we go to our requirements and let's put that in, replace this with equals, and I'm just going to get these in alphabetical order. Preference of mine doesn't actually matter. All right, so what I'm also going to do now is we're going to make a config.py, and this is essentially going to be just an easy way for us to essentially set our environment variables based on our env, as well as setting it in a way that we don't have to worry about copy and paste issues, because we're not going to use, except for this one file, we're not going to be referencing any environment variables as a string. We're going to be accessing it from this class that we're going to just call config. So config here, we have this awesome class. And what we're going to do here is we're going to import a couple things. We're going to import just OS, you know, the built-in operating system package. And then from .env, we're going to import load.env, and right when this file ever gets loaded for the first time, we're going to run load.env. What this does, it'll take anything in our .env file and make them environment variables in terms of the scope of this project. Which is great for us locally. However, in production, we won't actually have a .env file, or in theory you could, but I don't recommend doing it that way. You would actually set these environment variables, and the .env thing will, still try and load stuff. It won't find anything. That's fine, and you'll be using the main environment variables. Okay, so in here, what I want to do is just actually make kind of references to these. So if I actually open up my env file again, I essentially want to have these all here. So essentially we'll have like AWS storage bucket name, this, region, this. I'm keeping all the naming the same, just so there's no issue and we don't get confused somewhere down the line. So that's all we need for this file. And I'm going to actually, before I forget, put in my access key ID and access key so that I can, this will actually work when we get to the point that we're using it. However, I will be pausing for a moment to do that. All right, they have been added, and we are good with our config. So now what can we do with this? Well, in our upload client, for instance, we can actually go from config, import config. So we're just importing that config class. And now the cool thing we can do is actually set these based on that config. So the variables we want to set are the AWS access key ID, and we're just getting that from config.this. And if I click on this, I can see it's getting it from the environment, all good, so on and so forth. So we'll have those three things there, the region name, et cetera, et cetera. So now we actually have a client to work with. First thing we want to do is handle the actual getting of the pre-signed URLs for the multipart upload that we're going to do. So let's just kind of get that stubbed out right now. I'm going to call this get pre-signed multipart right here. And because this is a class, self needs to be the first parameter so that we can reference things within this class, such as the S3 itself, that kind of thing. Then when we are doing this upload, there's a few things we need to be passing along about the large file itself. One we will call key. This is essentially where it will be stored on AWS. So this could kind of be the file name, but it could also be actually a whole path. It could be, something like, upload / file / one / something .jpeg or whatever. That's what the key is. So it's basically like a path, not path on the local file system, because this file is never going to exist on the server's local file system, but a path to where it will exist remotely. The next thing we want is content type, which will also be type string. That's just something like image / JPEG or application / binary. It's the MIME type essentially. We also need to know the file size because Amazon needs to know how the chunks are going to work and all that kind of stuff, what to expect, so it can pre-sign things. And that's going to be an int. So this is actually going to be in bytes. It's not going to be megabytes, kilobytes, terabytes, or anything. It's just bytes. So that's file size. The next thing is we can set an expires, and this is just how long for this link to expire. And we'll just set a default for this of 3,600 seconds right there. And then chunk size. So how much do we want to break this up? And we'll also set a default here. And I'm going to use 50 times 1024. And we'll just do to the power of 2. So that'll be a pretty large size chunk. And I think that should work fine for us. So this will return something, but we haven't actually defined what it will return yet. So we'll eventually put something here just to keep everything, our compiler happy and type safe. And let's just do a pass for now, and we'll come back to this. There we go. Back to our main.py, and let's actually change this here. Let's make this URL called start upload. And within start upload, what we're going to do is actually call that function. So we'll need to import it. So we'll go from upload client, import upload client. And we're just going to create something called client here. And it's going to be an instance of upload client. So we have kind of the singleton of the client that we can do things with. So when this is called, essentially what we're going to want to do is get some data and actually run that function. So I'm going to just make something called result equals, and we can just do client dot get pre-signed multipart. And here we're going to pass in, things like the key, things like the content type and the file size. As I'm sure you can remember, it wasn't that long ago. We're going to have to pass in at least these things here. We don't have to pass in this, but we could. Same with this. So we don't have those yet. So let's just kind of have this like this. And ultimately, we're going to, return something like this for now. Okay, so let's figure out what we need to pass in, as well as what will come back. What's really cool about Fast API is we can define essentially like models, or you can think of them as serializers of what the input and output would be. So I'm going to make a new file called models.py. And in our models.py, we're going to first of all make the start upload payload. So I'll just put this over here so we can kind of remember what we're working on here. So essentially, this is what's going to get passed in as post parameters on this. Speaking of, before I forget, this needs to be a post. We're not going to be doing a GET request. This will be a post request because we need to send actual, data, not just, a URL. So we'll make something called start upload payload. And this needs to inherit something that comes with, essentially comes with Fast API, but ultimately it's from a library called Pydantic, which is a really awesome Python library. And we're just going to import base model. And this will extend base model. So we get all the good things that come with base model. And all we have to do is configure what fields we're going to allow. So we want something like file name. That's what I want the client to send up for me. That way we can preserve that file name. And when someone re-downloads it, it's not just like a random gibberish name. So we want to capture that. We also want to capture the content type, because again, we don't want the file to get uploaded to the server. So we're not actually going to be able to read the file itself from the server and be like, okay, this is a WAV file. No, we need the client to essentially do that for us. Lastly, we need a file size. And for similar reasons, we need the client to send it to us. And that will be an integer because it will just be in bytes. So now what we can do over here is from models, import start upload payload. And what we can do here is actually, back in our main.py, is we can pass in something like payload here, and we can say what type it is. And this will allow us to have nice IntelliSense from our IDE, but it also is used by Fast API to generate the docs, which I'll show you in a minute. And let's actually just rename this start upload just to keep everything really consistent here. So there we go. Let's just save all of this stuff. And what I can show you is kind of cool. We can go to /docs, and we have to make sure we're running our server. So let me just run this again. And we actually see the start upload here, but what's cool is we actually have the start upload payload here. So we can actually see what is expected. So we don't have to go back to the code and remember how it works. And obviously another developer or someone integrating with your API can understand it. And here it's cool too, because it actually just shows you, hey, here's an example of a request body. And then, okay, here's a successful response string. Now, that's just the default because we haven't actually done that yet, but let's figure that out now. So we're also going to have a start upload response, which is going to extend base model. And the things that we want to be sending back when a file upload actually happens is a few things, and it'll make probably a bit more sense when we actually get this working, but we're going to get a list of URLs, as I kind of explained in the initial lecture. So we can just mark this as URLs, list string. We're also going to be getting a chunk size back, or we're going to be sending back a chunk size so that the browser knows how many, how big are these chunks going to be. So that'll be an integer. We're going to have a key, because although the client already kind of sent up the key, server side, we might want to do things like normalize and sanitize that key, as well as maybe it gets put in a specific folder that the client isn't aware of. So we want to be sending that back so it knows where to actually upload to. We're also going to get an upload ID, and that comes back from Amazon, which is something that kind of connects all these files together. And then most importantly, or I guess equally as importantly, none of this would work without it, we're going to have something called fields. And this is actually sort of some data that the client needs to include. It kind of has some token data and stuff like that, the temporary sort of stuff, so that when it's through the upload, Amazon can be like, yep, this is valid, you're allowed to do this. So those are the things that are going to come back. So now what we can do is actually mark this right here as sending this back. And if we save everything and just reload our docs, we actually get a bit of an advantage here where we see it as a successful response. Okay, here's what's going to come back. Great, I can work with that, as well as when there's a validation error. And this is happening automatically because it knows what is required. This is kind of telling you an example. So if I just try and hit this, for example, right now and go execute, I will get an error back, saying something went wrong. And we go here. Oh, the error actually is even worse. We're getting 3 required position arguments key. So let me just actually pass in some things so I can demo what I was saying. So what is it? We need like a key. It's a content type. So I'll just conform to the shape of this, and let's just do 1. So now we shouldn't get that 500 error. And let's actually execute again. And here we get, fields required, So it's telling us there's some issues, all these things even on the response right here. So anyways, long story short, we have the docs, which is kind of cool. Okay, let us get to the next part. I'm going to close everything, and we're going to open up the upload client. And this is where, the work will be done. Okay, first thing we need to do is, based on the chunk size and the file size, we need to know how many chunks there are so that we can tell AWS how many URLs do you have to generate. So we're just going to make a variable called total chunks, and we're just going to go and essentially we want to take the file size and divide it by chunk size. But we need this to be an integer. Right now, this would be a float because it's not likely going to be an even number. So we need to round this. So for that, we'll import math. And we can just do, math. Specifically, we don't want to do math.round. We want to do math.ceil because we always want to go up. If there's a bit of a remainder, we don't want to round back down because we won't get the full file. We always want to do extra, meaning, in theory, the very last chunk might actually be a very small file. It could just be a couple bytes, but we have to make sure that we're accounting for it. So there we have our total chunks. Then we need to create our payload that we're going to be sending to AWS. So we're just going to call something payload. And here we need to, first of all, define an ACL, which is kind of like the permission type of this object. And we want to use public read, meaning anyone who has this URL of this finalized file can read it. Now, that might change for your use case, but that's what we want to do here for us. We also need to have what bucket we want to use. And for this, we're going to use our config dot AWS storage bucket. There we go. We also want to have a key. Notice we have like capital letters being used here, and that's just how Amazon works. In most of probably all of their APIs and stuff, they kind of follow more like a Pascal case. That's just what they do, so we conform to it. Key. Now key, we're just going to pass in the key that came directly from when we call this function. Okay. Then we need to do a content type. So we'll do content type like this. And again, we'll just pass our content type through. So now we have a payload. Now, what we can do is we're going to essentially go self.s3. So that's our S3 client. And we're going to do .create multipart upload. And here we want to pass in that payload. So I'm just going to go and pass in payload. Great. And we want to capture this result. So I'm just going to call this data. And we're going to go like this, and we're going to create it. Now, what I'll do is I'll actually print out what data looks like just so we can kind of work on this as we go. So let's just save this. We get the nice refresh. And let me actually just go back to our main.py right now. I'm going to just temporarily get rid of this so that we don't actually get an error here. And let's just try this out. So I'm just going to hit execute. And we got an internal server error, and it's because, it's not expecting this isn't really like the correct data that we want to send up. Oh, wait. Let's see. Create Multipart Upload only accepts keyword arguments. Oh, yes. There is one issue I made. We don't actually pass it in like this. We actually have to pass it in with a double star here. And that in Python will just let it be sent essentially as like keyword arguments there. So let's just try that. And let's hit this again. And we get back, obviously, a response that's just empty because that's what we changed this to do. But we can see what came back. We got a request ID, we got a host ID, we got an upload ID, we got all these lovely things that we're going to be able to do things with. So let's keep working with that then. So again, we have our upload ID, and we can capture that in a variable. We'll just call it upload ID, and it's going to be equal to data upload ID, just like that. Then let's make a variable called URLs, and we're just going to call this, we're just going to make this an empty list here, and we'll just kind of work with this. And what we need to do, because we know the total chunks, we actually have to loop through essentially the amount of chunks that we have and essentially figure out what the signed URL will be. So what we want to do is we want to do for I in, and to do like a standard sort of for loop in Python, we actually do it in a range. And we're going to start at 1. And we're going to take total chunks and add 1 to it because we're starting at 1 and not 0. So this will essentially loop through for every chunk that we have. And within here, we're going to go signed URL equals, and we can go self.s3. In this case, we're going to generate a pre-signed URL. And we need to decide what kind of client method this is. So we can actually just go client method equals, and we're going to do upload part because it's just a part that's going to be uploaded for this URL, not an entire file. Then we have to pass in some parameters here, and the parameters, we're going to get our bucket again. So I'll just grab this here because it'll obviously be the same bucket. Then we need our key, so I'll grab that again. Then what we need to do is determine what's the part number. So when all these get reassembled, this is going to be a certain part. And that's why we're starting at 1, because the part number actually needs to start at 1. So we're just going to use I for that. That's just the I in this range. So it'll be 1, and then 2, then 3, and so on and so forth. And then an upload ID we need to pass through to connect these all together. So the upload ID will just be this upload ID that we already captured here. So let's just put that there. And we are good on that point. And then after all this, we can also set an expires at. So we just do expires in, and here we do expires. So we're not setting a date of when it expires. We're saying it's going to expire in this case, 3,600 seconds. So let's get that. And what will happen is we get back a URL here when this finishes. So we want to take our URLs, and we're going to go and append this signed URL. So now we'll have a list of URLs, and let's actually print out, what those URLs will look like by trying this one more time. So we'll go back here, we will execute, and here we get back, in this case, just one URL. So let's make some changes actually to a few things here. One of them, let's make, I'm just going to make this test.jpg as an example, and let's make the file size quite a bit bigger. I'll make it something like this. And let's also just, for debugging purposes, let's make our chunk size smaller. That way, we can kind of see the chunking happen without having to have a huge file. So let's run this again. And in theory here, if I did this right, okay, we have one URL, 2 URLs. So we're actually getting 2 different URLs. Let me just try and make this a little more readable here. That didn't really help that much, but essentially we have a URL. Let's go like this. So one of them, it's the bucket name. It's saying the part number in it. The upload ID, which you'll see are going to be the same between all of these. It's this really long random string. We have the AWS access key ID, which is a public key. It's fine to be in a URL. And then we have the signature, and the signature varies between them. But this is essentially what's going to be used and passed up later to essentially be like, yes, this is valid, and so on and so forth, based on things like your secret key and other cool cryptography things. So that's the URLs that we're getting back. So that's pretty cool. So now what we want to ultimately return from this method, if we import our models from models, import, and we're going to import our start upload response. So let's actually return a start upload response here, meaning we can go like this, and we can actually mark this as returning a start upload response. And let's just return a start upload response. Now, what does this need again? Well, let's open it up. So we need the URLs. That's easy. URLs equal URLs. We need the chunk size. So we already know that based on this right here, based on what was actually passed in or potentially set as a default. So we'll just return that back to the client. We have a key. So key equals key. Then upload ID, pretty easy. Then we have something called fields. And fields, we actually need to set right here. And we're going to have a couple things. We're going to essentially send back the content type that's going to be used and the key again. And this will just allow our client-side integration to work a lot smoother. Well, it can just essentially put these in the headers without thinking about anything. So that's what we're returning back. And now if we go back to our main.py, we should be able to just return result now. And in fact, we can keep this one line better and just do return this. So let's hit this again. and go execute. So there we have URLs, chunk size, blah, blah, blah. Awesome. Now, let us now actually make use of this payload here, because we don't want to just be hard coding data. We want the client to be able to say, hey, this is all my stuff. So what we can do is for key, this is pretty simple. We can just do payload.key, or sorry, payload.filename as an example. For the content type, we can just go payload.content type. And for the size, we can just go payload.file size. And this will work just fine. And I'll keep this on for now, just so we can kind of test things a little bit better. However, I don't want to rely on the client essentially determining the key. It could be the same file name as something else, and if I'm not doing anything smart, we could run into conflicts. I find the best way to do this while preserving the file name is we actually put each file in its own unique directory. That way there's never going to be conflicts and anything like that. So to do that, we're going to create something. We're going to create the key ourselves, essentially with an F string, and we're still going to use that file name that got passed in, so payload.filename. But before that, we're going to actually generate a random string and put a slash between them, which will essentially define it's going to be in a folder of this random string. And one way to make a random string is we can just import UUID, and we can just go UUID dot UUID v4 right here. Actually call it, and now we'll use this key instead of this right here. So there we have it. And now let's try to run this, and we will see hopefully an error. So we get required. Okay. Realize the reason we didn't get an error is because Fast API or Swagger automatically puts in sort of an example thing for you. So let's just for now omit one of these as an example and execute just so we can show errors coming back. So we got this JSON invalid body, JSON decode error, something. Oh, that's actually just because there's a comma there. Let's try it again. So here we get file size missing, et cetera, et cetera. So the client can be like, oh, you forgot to do this or whatever. But we can put this back in. And let's actually make this a little more like it will be. Test.jpg. This might be something like image/jpg, and file size, maybe is a pretty big number. So now when we execute, we actually get a whole bunch of URLs, back, and all the stuff we need to actually, work with this. Okay, awesome. Now, the next step of this, so that will allow us, to do everything from the client side to actually get the parts uploaded. We have all the data we need, we can do it. However, we need to essentially, when everything's uploaded, also tell AWS, hey, we're done. All the parts are there. Finalize this file. And that's where our second method will come in, which we'll start by doing in our upload client here. I'm just going to remove some print statements. And within our client, we're going to make a new function, and we're just going to call it complete multipart upload. And self, of course, because it's class. And then this is going to require a key that's going to be of string. It's going to require that upload ID that we were capturing before, as well as something called an etag string, which is a string. So I'm just going to pass this for now, and let's go back to our client, to our main.py, and let's create another endpoint, because our client will be the one having to call this, not the server. The server won't know when this is done. It has nothing to do with it. It's just orchestrating everything. And we'll just call this complete upload, like that. And I'm just going to go async def complete upload. And there'll be a payload that needs to be put into here, which we will figure out in a moment. So I'll just keep that empty. And we're going to do something in here. Well, we know what we're going to do. We're essentially going to, I'll just do something like response equals, and we can, let's call this result just to keep it the same as we did before. So here we would use our client dot complete multipart upload, and we'd have to pass in those things. So we need to figure out this payload. So let's get our models open here, and we have a class. We're going to call it complete upload payload, and this will be a extending base model, of course, again. And here we need the client to pass in a key, which is a string, that upload ID, which is also a string, and those e tags, which is a string. Then while we're here, let's just make our response, just so Swagger will have the nice docs for us and not just be kind of unknown. So we're just going to do this. And all this really needs to return to the client, although in your use case, you might want to return some other metadata about it. All I really care about is what's the final URL of this? When everything's said and done, like, where's my file? So that's what we're going to return, meaning now we can import these two things. Complete upload payload and complete upload response. And let's actually decorate the stuff that we meant to decorate. So we want this to return a start upload response. Our payload is going to be of type this, and it's going to return a complete upload response. There we go. So now from our payload, we can of course pass these things in, right? So the first thing is we're going to take payload.key. The next is the upload ID, so payload.upload ID. And payload.etags. And let's save that. We have some error here. Let's just figure out what that is. Oh, that needs to be like that. Okay, cool. And we need to save all of our files. We're getting this error here because I didn't actually save my models file. All right. So we have that, and ultimately what we want to return here is, we'll conform to what this is supposed to be, and really we just need to return, we could do a couple things here, but let's just return the complete upload response, and we're going to have to pass in a URL equaling to something, which will probably come from this result. So let's just put result for now, and we'll come back to this when we know how this will actually work once we have this side done. Okay. So first thing, our client is going to be sending up essentially a comma-separated list of all the e-tags it's collected along the way. So that's why I'm calling this e-tag string. It's not a list right now, but we're going to turn it into a list just by going e-tags equals, and we can just go e-tag string dot split, and we'll just split on the comma. And now we'll actually see this is going to be a list of string now. List string. Yay. Then we need to create essentially this map of our parts. And this one, we could write this in a, sort of like a for loop and kind of loop through all the things. But I'm going to do this in a sort of a one-line fancy way, and hopefully it'll make sense. So let me just type this out because I need to have a list. And within the list, we want to have a thing called e-tag, and it's going to be using e-tags I in this loop. But we also need to be saying what part number we're on. So we're going to actually take the part number, and we're going to use that same I that we'll have access to in a minute when I finish this. But we need to add 1 to it because, again, the part number starts at 1, not at 0, which is a funny decision, but I'm sure there's a good reason. And we're going to make this a loop by going for I in range length of e-tags. So this is just a list comprehension in Python. So it's just, instead of making a loop where we're looping through this and just like creating this and putting it in memory and then returning it, we can do this all in one line. And it's clean, it's nice, it works great. In the comments, if you think that's a little bit too confusing and you want me to write how this could be done as a loop, definitely let me know. And or paste this into ChatGPT, and I'm sure they will tell you as well. But I'm happy to help as well. Okay, so now we're going to get something called response, and it's going to be equal to self.s3 and we need to do now complete multi-part upload. And here we need to pass in the bucket. And here again, we'll use our config.aws storage bucket name. Key, capital K, is going to be equal to the key that is being passed in to this function. Upload ID is going to be obviously the upload ID being passed in. And then we need to say, we use this key called Multipart Upload. And here we actually have to pass in a dictionary with a key of parts. And then we actually use these parts that we have created right here. So of course I could just go and also replace this and put this here, but this is like even more confusing. So I like to kind of, make decisions on when to make something a variable, when to do it completely all in line. And I think this is the cleanest way that it could look. And here we'll return response. And what I'd like to do here, just so we know how stuff will work, is we're just going to print response. And over here, instead of doing this, let's just do, https://test.com, just so we can kind of see things going. And in fact, you know what? Let's actually print the result. Okay, so let's save all of this. We now have, the client. You have the API endpoint here. We have the actual implementation of it, and let's go back to Swagger, and let's just refresh, and let's see. We have complete upload, and it's telling me I need all these kinds of things. Now the problem is if I just try this out, I'm not going to, be able to do this. In fact, I'm getting an internal server error. E-tag must be one of this. Oh, I think this should be, E-tag like this. So I'm glad we caught that. Let's try executing again. Internal server error. So now, no such upload, and that's because I'm kind of just putting in this like sample data. So let's actually see. I'm not sure if I'll be able to do this because it might be a little bit complicated, but let's see if we can do this. The full process. So I'm going to put chunk size back to this, and actually, I realized, we can't really even fully test this just with Swagger because we need the browser implementation. We need to actually upload this. And so I can kind of, show you this, show you that. But what we actually have to build is we need a way to actually upload S3 because, again, our server is not responsible for uploading the file. It's just orchestrating, the metadata and permissions and all that kind of stuff. So in the next part, we are going to create the JavaScript side of this, which will allow us to kind of actually see this thing fully in action, and then it'll all hopefully make sense, and everyone can use this if they want, and make their uploading process a lot better. So we will get to that. I'm going to move to that. Right now. Let's just do it. Why wait? It's one good reason to wait. I did want to do a quick review of this now that we've kind of see the code in place. And what I'll do is I'm going to mark all the browser stuff here. I'm going to see, can I just change the color here to like red? Because we don't have this part in place yet. So this is really what we have to build, which doesn't, seem like that much right now. And then, I guess this also, let me, okay, anyways, this stuff's red too. Imagine it's red. Okay, cool. We built that. That's fine. It's going to send some stuff up. That's what it has to do. So server, let me get started on that, is essentially it going and from the start upload thing and getting the data it needs, like the content type and file size and the key, like we said here. And it will go and talk to S3. So that is happening right here, right? We're going and we're actually making a call to our S3 and getting all these URLs back. So sends back a list of pre-signed URLs. Thank you. Then we send it back to the client. So we don't have that part yet. We don't have this part yet. That's coming. And it's going to talk directly to S3, so we don't have to do any work on the server there. Cool. This will be sending back e-tags. So again, don't have to do anything there. This we have to build still. Cool. Sends e-tags up. So we have this part now. This is actually what is happening in the second API endpoint we made, which is right here, complete upload. We essentially send up, the e-tags as well as some other metadata that we need, and goes, and it then talks to AWS and finalizes the file. So really, we're almost there. The server side's done, unless we made a mistake that we haven't noticed yet. Okay, now, without further ado, let's build the front end part of this. I'm going to close everything, and let's open up that index.html that we made, and this is where we're going to do everything. Now, of course, you can adapt this to React. You can adapt this to Vue, Next.js, whatever, whatever floats your boat. And I'm using Vanilla.js because it's probably a lot easier for someone to adapt Vanilla.js to their framework of choice than to actually, take React and convert it to Angular. There's a lot of disconnects there. So everybody uses Vanilla.js, and we're just going to do this in one file. I'm not even going to build this I'm not using any build engine, Vite or anything. We're not putting any CSS. It's going to be very basic. So first of all, let's just get our sort of HTML document set up here, and we're going to have a body tag, and we're also going to close our HTML, and we're good. Cool. Now, what we're going to want is we want a file input. So we're just going to make a input type file, and we're not going to allow multiple. Of course, you could support multiple and definitely do this with multiple, no problem. We're going to keep this simple. And then I'm just going to put a divider here, which will come in handy later. So we have our HTML. The HTML part is done. Let's go to here, and now we'll actually go to, just localhost, and I'll just zoom this a bit. We have this browse. Cool. I can, pick a file, and let me just find my, have some files here. Got a file. Cool. Doesn't do anything. It's there. It's ready to go. So now, after our HTML, we're going to just make a script tag. So yeah, we're doing this in a very vanilla way. We're not even making a JavaScript file. We're doing it all, essentially in line. And there's no problems because I'm just trying to teach how this could work. So here, let's just get our upload input. And it's going to be equal to document.getElement.id. And we just need to pass in the ID, of course, of that input like this. So now we have access to this element. And what we can do is we can go upload input.onChange, just like this, equals a function. And we get the event back. I'm going to make this an async function. And we just have to do our little braces like that. And when this happens, we can get the file. We can go const file equals, and we can take our upload input, we can take our event.target.files, and then the first file in it, because it actually comes back with multiple, even though we're saying not multiple. That's just how it works. And then we want to, of course, check if there is a file. And let's just go here, alert, file. Cool. And just make sure that all that's working. So I'm going to refresh this. I'm going to go and pick a file, and we should see file. And if we refresh again and just cancel this, we shouldn't have the alert. So we're only running this code when a file is there. I'm going to open the console as well, just because we're going to want to be seeing some things here. And let's zoom that a bit. Okay, so if we have a file, there's a few things we want to do. First of all, we're going to get the details of that file. First we're going to call the initialization. So I'm just going to call this details, but we're going to essentially await something that I'm going to make, initialize upload. And here we're going to be passing in the file.name, the file.size, and the file.type. So that's the things that our initialize upload will need. Once that's done, we need to, of course, get the e tags. And that's going to be done by actually uploading the file itself. So we're going to go await upload, and we're going to call this function upload to S3. These don't exist yet. And what we're going to require when we upload S3 is obviously the file itself. We want to get anything back from these key. This is going to essentially return that data that we need. So we're going to have something like details. We're going to maybe get a key back from that. We're going to have to send the chunk size. So that will come back too. What else do we need? Oh, that list of URLs is going to come back from that. So we'll call that details.urls. And if this isn't making a lot of sense right now, let's just open up our models again, because essentially what I'm expecting is this initialize upload is going to essentially return, all this stuff to us, right? Once we make it. And we also want to pass in the fields that come back. So once we get that done and the files are actually uploaded, all the chunks are uploaded, we're going to then complete the upload. And for this, we're going to want a URL to come back, and we're going to go await, and let's just call this complete upload. And this will be the one that is calling the complete upload. So the things we're going to have to pass in is going to be the details.key that we got originally. We need the upload ID to kind of stitch it all back together. So upload ID, which again comes back from here. Here we go, upload ID. And we need the e tags, and that's what's going to come back from this upload function. So that's kind of my plan here. And then, if the URL came back, meaning like there wasn't an error or something like that, let's just call like a function called handle success that we'll make and actually just pass in that URL. And just to do something fancy, we can also go pass in the MIME type. So file.type, and actually let's pass in whether or not it's an image, because we'll be able to do something more fancy if it's an image in terms of displaying it, versus if this is like a binary file, we're not going to be able to preview it in the browser. So we're just making plans for that. So this is kind of like our intention here, the sort of process. We first do the initialize upload, which ultimately, if we open up our main.py, is going to call this function, right? Through an AJAX call. Then we're going to be doing the upload to S3. That's not going to talk to our server. That's actually going to talk directly to S3. As we know in our sort of diagram here, this stuff goes right to S3, this sort of phase. And then the third phase, again, goes through our server to do the complete upload on our behalf. Then if everything is good, let's actually show some user input, just so we know it worked for our own purposes. All right. Okay, so let's sort of make these happen. Now I might be able to do, no, I can't. I know in some languages you can do command dot and it will kind of be like, create this function for me. But we're not there with, I guess, just a HTML file. Okay, so let's make this, and I'm just going to put this here after, sorry, right here. It shouldn't be part of this on change. It should just be its own sort of high level function. So initialize upload is going to take the file name, it's going to take the file size, and the content type essentially. So we'll have that one. We'll have our upload to S3. Now you notice this is JavaScript. This isn't TypeScript because I'm doing this right in the browser. There's no build process, so I can't put fancy things like string and stuff like that, unfortunately. And that's fine because again, this is just a demo. You can of course build this in TypeScript and compile it yourself and have all your type safety. Sorry, I don't need that yet. What else do we need? We had upload to S3. We had complete upload. So let's get that in place. So complete upload is going to have a key, an upload ID, and the e-tags. And then let's also have a handle success. And I'm actually just going to paste my success code in here because it's a little bit tedious and it's not really relevant to this. But basically how it's going to work is what we're going to do when a success happens, we'll console log the URL. Just so we have it in our console. That's fun. Then we're going to, using vanilla JavaScript, actually create a new section in the page. If it's an image, we're going to create an image and set its source to that URL, give it a width, and append it to that section. But either way, whether it's an image or not, we're actually going to create a link, make it target blank, use the URL for it, put the URL as its text, et cetera, et cetera. Just to, I guess, see this in action, let me just... what we'll do is we'll just call that function handle success https:// let's just use like placekitten.com/500/500 and pass true in because this is an image. And just so I could show you what we plan to do when this is all together. So when I refresh, handle success because actually, okay, let's just do it here because we need that to exist. Okay, so I'll just browse any file, and then we should actually see that it gets the, I guess this image doesn't exist. Oh, placekitten is down. No, unless it's like .org. I don't think it is. No, it's not. Okay, well, you get the idea. We're going to basically like show the image here and then have a URL to it. That's the plan. So let's get rid of that. Yeah, that's just some lovely vanilla JavaScript to essentially create stuff, and append it to the DOM. But not really necessary for the scope of this project. All right, time to initialize the upload. Let's figure that out. So this is an async function, meaning we can do things like await. I am going to wrap this in a try catch because it's a network request. Something could go wrong. And let's just have something called error. And in the case that there's an error, we'll just console.log, like the word error, and actually pass the error through like that. Cool, we have a try catch. Now, what are we going to do inside this? Well, let's, first of all, let's await. We're going to use fetch. So we're not even using like Axios or, jQuery or anything like that to do it. We're just doing a vanilla JavaScript using the fetch API. And with fetch, we actually go /start upload. And it's cool because we don't have to pass in like localhost or anything because we're serving this from the same server. So just the / relative URL will, make this work. So we'll do start upload, and then we actually have to pass in some fetch. The second argument has all the options. And in this case, we need to say its method, and it's going to be post because if we go to our main.py, we said that this is a post request, start upload. Cool. Actually, I'll keep that open. It might be handy. And we also need to set some headers here because we need to use content type of application JSON, application/JSON, because we're working with a JSON-based REST API. So that's our headers. And then we also want to pass in our body. And for this, in order to make this work with fetch, we're going to stringify our JavaScript object that we're about to make. So I'm just going to wrap this in json.stringify. And in here, we're going to create a object. And what do we need to send up? Well, let's remember what we need. We need a file name. So we'll just do file name, and we'll pass in, what do we have? File name. Cool. What else do we need? Content type. Oh, good. Do we have that? Yes, we do. It's called content type. And, I missed. Let's do this in the right order. File size. The order doesn't actually matter, but I like to be consistent. File size. So we'll be passing in all those things. Awesome. Great. So right now, we've got the file, and we're able to get those things really easy in the browser. We can get the name of the file, we can get the size, and we can get the type, and that's just part of this file object here that we have in there. So there we go. We await, we fetch. Now we do want to do something with this, so let's actually make something called response equals this, and we can check if the response is not okay. Let's just throw an error, throw new error, and we'll just say network response was not okay. Sure. Then, assuming it is okay, which it is at this point, we can go const result equals await. Something that's weird about the fetch API is even to convert your response to JSON, we actually have to await it still. So we'll go response.json. There we go. So we do that. And then we'll return the result from here. So this will get returned from our initialize upload. So let's see how that works. So what I'm going to do is I'm going to comment out a few things here because obviously these won't work yet. And let's just actually go and console log our details and see if we've got all this working. Make sure our server's running. Awesome. Let us rebuild. Let us browse and choose a random image. And we get back this object, right? If we actually look at the network inspector, we can see this happening. We have our start upload, and this is all the data being sent up. Cool. This is our request. This is what's being sent. And this is our response. We're getting back a bunch of URLs. Is it many? It's 2, which is great. We're getting back a chunk size, all the things that we're kind of expecting. So this is working, and we are good. Let's figure out the next part of this, uploading to S3. So this will get called. We'll be passing in, the file itself again, because that's really important. We need to upload the file. We need the key that's coming back from the server, which is why we're passing in, details.key that came from this. We also need to know the chunk size and the URLs to use and the fields. So we're getting all that stuff, luckily, and we should be good. So let's figure out how to make this work. So we're going to be collecting all the e-tags because this is a multi-part upload. So let's just make a variable called e-tags, and it's going to be just an empty list right now, but we'll be doing stuff with it as we go. Now we have to break our file into chunks. So let's actually make a function to do that. We're going to call it split file into chunks, and this will require a file to be passed in as well as the chunk size, we'll say. And I just forgot we need to do equals and then arrow function and like this. So let's check out that function here. So we'll start similar. I'm actually going to copy this because it's kind of similar. We're going to be starting with something called chunks. And we're going to start at 0. So we're going to make a variable called start equaling 0. Then we can do a while loop here. So we can go while start is less than file.size. What we can do is we can get the end of this file or this chunk by going math.min. So we want to get the min, and we take the start and we add the chunk size to it, and then we pass in the file size. So this will get the minimum between these two numbers. I forgot an equal sign here. So like there's going to be 2 things passing. We're passing in like the current position and the wherever we are in this loop, essentially, plus the actual chunk size. However, we don't want this to overflow. Like if we have a remainder that's less than the chunk size on the very last one, we want to make sure that the last chunk is just using the file size. So that's why we have to wrap this in a math.min. Otherwise, we'd have a problem. Then we just basically go chunks.push, and we push in the file.slice. So we're actually going to slice up the file's bytes. We're going to take whatever the start is at this point and the end. So we're just kind of making like, hey, here's a chunk of that file, put it in there. And then we need to take the start and make it equal to the ends. Otherwise, this loop will run forever. So basically, like it will run it again, but start will be slightly more. Run it again, start will be slightly more, et cetera, et cetera. Then at the very end, we just return the chunks. There, we have a nice little splitting file into chunks. So let's make use of this. Let's just make a variable called chunks. And it's going to just use that split file into chunks, pass in the file, pass in the chunk size. Done. We now have, this should be, now I don't know if it will tell us nice stuff. It's a list of any. Cool. It's as helpful as it can be without using TypeScript, I guess. Okay, so what do we do next? Well, we have the chunks. We need to loop through them. So we can just do a simple for loop. We'll just make let I equal 0. We'll do I less than the chunk chunks.length. We want to loop through all the chunks, and I++. So just a simple for loop, nothing fancy there. In here is where we're actually going to do the uploading of the chunk. So let's do this in a try catch again, because there's a network request. It's just good practice. And here, if there's an error, we'll just console.log error. All right. And we should probably do something in our try thing. So what we need to do is actually upload the chunk. So we could put all the code here, but let's actually make, again, another sort of like function here that's just for uploading a single chunk. So we'll make something called upload chunk. And what we need is a URL that will be used. We need the chunk itself. So that's like the bytes of that. And again, I need to do this. What else do we need? Oh, content type. That's going to be needed because we have to tell AWS like, hey, this is a image or whatever. And we need those fields, and that's kind of like the metadata that just needs to be put in the headers so that things work. So our upload chunk. Let's grab this try catch again, because this also, this is a network request for sure. In here, we're going to go const response equals, and we're going to await fetch again. So that means we need to make this asynchronous. We're going to await fetch. We're going to pass in the URL that we need to use here. Then for the options, it's actually a put method for here because it's a multipart upload, and we're not actually uploading an entire file. We're uploading a part. So they decided put is the right method for that. And the body itself, we're just going to send the chunk up. It's just going to be like binary data. Cool, we're sending the chunk. And let's just go if response.ok, and we'll just negate that. We will throw another error, and I'll just kind of do what we did before. Throw new error. Otherwise, we're going to return the response. Now, what's cool or interesting and how this works, the E tag isn't, we actually don't get any body back from here. No JSON, no text, no anything. But there's actually something in the header we're going to be getting back. So we have to look into the headers, and we have to call .get. And here we have to pass an E tag like this. E tag, just like that. So this will actually get a string value, and we'll be returning it here. So, okay, this is our upload chunk. Cool, Joe goes and uploads. So let's actually use that now. So let's just call upload chunk, and we need to pass in a URL. So how do we get that? Well, we can get the URL by, we are in this loop right now. We have a bunch of URLs right here. So we actually want to use the URL at whatever index we're at right now. So we'll do that. Similarly with chunks, we have a whole bunch of chunks, and we want to just send in the one that we're in the loop for right now. File.type. This won't change in the loop because it's the same file obviously through it. So we can just use file.type. And then fields we want to pass up too. Which actually I realized, I think this was something when I was playing around with things. We actually don't need fields here. We're not actually even using it. So let's actually just remove that from this part of it at least. And what does this return? Well, it returns an E tag. So we can actually just call it E tag equals, and we have to await this. Otherwise, we'll just get a promise back. We want the actual result of the promise. And what we can also do is just a nice little, console log when the chunk's happening. When we actually have a upload chunk done. Cool, we get that. But let's actually take that etags value. Let's go etags.push, and we'll push that current etag to it. So then we'll be collecting this list of etags, meaning at the very end of all this, we're just going to return etags, which is exactly what we want, right? If we go back to our caller, etags, yep, see, we want to be getting etags back, and yay, we're getting etags back. Okay, what's next? Well, we need to do the complete upload, which should be sending us back a URL. So let's get that in order next. And, we'll have this console.log error. So completing upload, we're going to be calling our other endpoint. Let's go back here and remember how this works. So we're just calling, complete/upload, and we need to be passing in these three things, and we should be getting back, a dictionary that has URL as something right there. So let's find out how to do this. So we're going to do, again, another AJAX call. So response equals await fetch. And here we need to pass in /complete upload. to our own server. And some options here, well, we need, again, our method to be post. So we'll just go post. And for headers, we're going to be passing in content type. And we'll just do application /JSON. All right. Then body, we need to be passing in we'll use our JSON.stringify again, but basically what we're passing in, we need to conform to this right here. So how did this work again? Well, we have a key. So we'll just do key, and we'll just pass in the key that we sent here. Yay! Upload ID. And that will be, of course, the upload ID that we passed in, and e-tags. So e-tags, we are going to pass this up as a single string, not a list. So we'll actually take our e-tags and essentially join them with a comma. So this will just be a string, not a list, because that's what our server is expecting. Okay, so we have all that, and let's just find another instance of this. So I'm just going to do, if the response is not okay, we'll throw another network error. If I can find where we were, here we go. Okay, we throw it, and then assuming everything was good, we go result equals await response.json, and what we want to return from this is actually result, and we'll be getting back a URL, right? We're going to be getting back a dictionary. All I really care about on this, I don't need the whole dictionary for my use case. I just want the URL, and then we're good there. Okay, now this part we already know works, so we'll just put it back in, and hopefully everything's good. So one last thing we do need to do is we're just sending back this URL. That's not going to work. So let's print the result when we try this. So this won't work on this attempt. And hopefully it's just for this reason, and we didn't miss something else. We'll find out, and then we'll figure out how do we actually get the URL from that response. So let's just refresh. Let's grab an image, and let's kind of see stuff going. So we saw the start upload happen. Okay, everything actually worked the way we kind of expected. We got tests.com back, but let's walk through what happened here. So we did the start upload. We sent that request, the content type, the image, whatever. Then you'll see we actually did 2 calls to Amazon. Just 1 call. One of them is the option, just like, the headers and stuff like that. We only did 1 call because our chunk size is pretty large for just a single image. And we sent up, this is just binary data basically trying to be, displayed to us. But we're just setting up, the bytes, whatever, part number 1. And then we called complete upload. And in this, we are passing, a list of e-tags, which we just had 1 because there's 1 file, the key and the upload ID. And it returned to us test.com. And that's because we have test.com here. So I printed this out, and we'll actually see in here there's a key called location. And that's actually what we want to use because it'll give us the full URL with the bucket name and everything. So we don't have to determine what it is based on the key. We actually just get it back. So let's try this one more time. And let's go browse. Let's make sure I didn't miss anything. Yep. Okay. So let's go here, and let's just pick another image. And we see it all worked, and I made this clickable so we can actually open a new tab and get the full thing, and everything's great. Okay, let's just make just to kind of see this really at its full potential, I want to do 2 things. First, let's make the chunk size really small. And in fact, I'm going to make it even smaller. And let's just refresh, even though we technically didn't have to refresh for this. And let's just pick a different image. And let's actually see what kind of goes here. So we actually got, it did 5 different parts. Oh, we have an error here. Interesting. Or sorry, it broke it into 2 parts. Let me figure out what that error is. And the error was entity too small, because we actually are sending up too small of a chunk size. So I guess let's actually just put this back to 500. And I think I'm just going to have to find a bigger file to really see this, which we'll do in a minute. But let's see, an image might still... no, it is. Okay, so that is just 1. Let's find a bigger file then. We won't get the lovely image thing because I'm not going to upload an image, but let me upload something rather larger here. Found a file that should suit our use case. It's not huge, 126 megabytes, but let's try it out. It's just a installer for Postman. So here we go. We're actually seeing it, all these different parts being updated and going and going and going. And this is not the optimal way to do it. You don't want your chunk size to be so small that there's a lot of network requests. It's about finding that balance. And the default that I have in the source code is actually a really good size. Let's just so we know how long this will take, let's look at the start upload method and see if I can count. I'm not gonna be able to even count these, am I? Yeah, okay, there's a number. So there's actually, it's broken into 246 parts. So this will take a bit to do because it has to make a network handshake, for everything. But it looks like based on this right here, 50 megabytes, we're a little under halfway there. But you get the idea. It's going, it's pretty cool. And like I kind of teased at the start of the tutorial, this method, although will depend on your bandwidth and your network connectivity, AWS Multipart Uploads supports 5 terabytes. So you could upload a single file that's 5 terabytes from your browser, which I think is pretty cool. All right, so I'm going to just wrap things up here, and maybe in my little spiel, we'll actually see the final upload done, which would be kind of cool. But yeah, I hope you found this really useful. You learned a few things about working with Amazon and S3s and all that kind of stuff, as well as some Python, some Fast API, and some vanilla JavaScript, the forgotten language of our time. If you enjoyed this, and first of all, you can check out, I have the repo for this in the description, so you can grab the code yourself. Definitely, if you end up working this into a different project, whether it's like a Django or Flask API, post a link to your GitHub in the comments. I'd love to see, how it goes, and that would be really cool. So yeah, I'm going to leave it there. And we'll just kind of look at this again. This is what we did, and I think a pretty reasonable amount of time. And please, like, subscribe, share, all that kind of stuff that every YouTuber says at the end of a video. So I'll do it too. And thanks for watching, and we'll see you in the next one.